All right, this is Engineering 360 Hardware Description Languages, and this is the video for Lab 1. So first thing you want to do is you want to start up ISE Project Navigator. If I do a help about here, we should be using release version 14.1. All right, good. So first thing we want to do here is create a new project. So I can go to here, File, New Project. And let's see, I'm going to browse that guy to, let's see, EWU, courses, 360, not labs, but let's put it under videos. Okay. And then we will call this Lab 1, yeah, demo maybe, Lab 1 demo. All right. Now, the next thing, it prompts me for a bunch of stuff right here. Okay, so you'll notice Evaluation Development Board, none specified. Okay, no, we're fine there. The family we're using is the Spartan 3E. Now, you remember in class, there was also a Spartan 3. That's what the author's using in the text, but we're going to use a Spartan 3E. So make sure that's Spartan 3E. Now with the Spartan 3E, there's a bunch of different chips. You know, you've got the 250E, 3S500E. Well, that's the one we're going to use. Make sure that guy's set to XC3S500E. Now here we want the FG320, flat grid 320, 320 for the number of pins. So it's critical. You got Spartan 3E, the 500E, and the FG320. You don't have that, things aren't going to work. All right. Now this is HDL. Synthesis tool. Well, let's see, VHDL Verilog, that's fine. Preferred language is VHDL. If you're doing Verilog, you would change it to Verilog, but don't do that. Put it back to VHDL. And then down here, VHDL 93. Well, we kind of talked about that in 87 in class. Let's use VHDL 93, and apparently there's a 200X, but use 93. All right? And then we'll go to next. Okay? Once we go to next, it kind of gives me all kinds of information about my chip and project, and you can do that and click finish on that guy. All right, and now we have an empty project. Over here you've got on the left hand side you've got the design pane, view, you've got implementation or simulation. Now we can either implement this onto a chip or we can simulate it. If I simulate it, things kind of change up a little bit. Both in the top and the bottom, but we're not going to simulate, we're going to implement. We're actually going to put this onto an FPGA in lab today. So make sure that implementation is set. All right. So now the first thing that you're going to need to do is you're going to need to add a VHDL. Now if you notice, if I double click, or I open this guy one click, there's nothing there, empty view. So we got to add some files. So the way we do that is we go up to Project, New Source, and I have a choice, IP, schematic, user document, VHDL test bench, we talked about that in class. A library package, talked about that. We want a VHDL module. All right, so click VHDL module, and then let's type this in to be core. That'll be my, I'll just use that. I tend to use that name just like the core component when I'm demonstrating something. All right. Now, make sure that VHDL module is selected on the left. If it's not, you're going to run into problems. Okay. And then at that point, let's just click next. Okay. Now this guy's is a mechanism for setting up an entity, but I'm going to do this by scratch. So I'm just going to click a next and get out of here. But you could actually set up your entity using this this little dialog box here. We'll just click next there. And then the project navigator will create a new skeleton source with the following: project type, VHDL, architectural behavioral. All right, so we'll click finish. And now at that point, there's a stubbed out VHDL file. Now I'm going to get rid of all these comments just so they can kind of you can leave them in and change them and edit them the way you want, but I'm going to take them out just so we can focus on the basic VHDL. And as we said in class, you have libraries, you have an entity block, and then you have an architecture block. Okay, well we need to enter the stuff from the 1-bit comparator that we did in class. Okay, well the entity block is going to consist of a port statement. Okay, and let's see, what kind of inputs did we have? We had I0 and I1, right? And they were both of type N, and they were standard logic, which is 1 bit. And then we had an output called EQ, right? Output, and it was also 1 bit. And then we don't put a semicolon there, right? So that pretty much is my entity. All right, I'm going to save this guy. And oh, looks like I have a syntax error on 8. Okay, well, what's the problem with my syntax error? Anybody see? I see. Well, I didn't close out my port statement. There you go. All right, I did that on purpose just to show you an error. And now that error went away. So it's kind of compiling in real time behind the scenes. Okay, so there's got my library block. Now my entity block is completely filled. I've got 2 inputs, 1 output, both 1 bit. Next thing is enter an architecture block. Well, we did that SOP expression, and that SOP expression had 2 signals. We called them P0 and P1. And they were both 1 bit standard logic. Okay, so there's my local variables. Now I'm going to go down to my begin block. And let's see, we could put some comments in here. Sum of 2 product terms. Okay. And let's put those in there. Let's see. EQ was equal. Remember, you had the less than equal sign, and it was P0. And what did we do? We ORed those together, P1. Okay. And then I had to actually set up P0. And what was P0 equal to? P0 was not I0. And that was ended with not I1. Okay. And then there was P1, and let's see, that guy was I0 ended with I1. Alright, yeah, so there we go, and let's put a little comment there. These are my individual product terms. Okay. Now, we said that in a begin-end block that doesn't have a process statement, these are concurrent statements. So I'll let you rearrange those statements in lab and verify that things still work. Okay. All right, now what we have to do, now that we have our VHDL file, in order to make this guy work on an actual chip, we need to set up a constraints file, because we need to map our variables to actual pins on the chip. Okay, and that's because we're in the implementation mode. So at this point right here, we go project, new source. Okay, but I'm not going to do a VHDL module. I'm not going to do a test bench. What I'm going to do is a constraints file. Okay, constraints. Make sure that is highlighted. And then over here I'm going to type UC. Well, UC stands for, I use that for user constraints. So call it UC, and then make sure implement constraints file is selected on the left, and then click next and finish. All right. So at this point right here, if you go over to the left window, Lab 1 demo is the project. It's being implemented on an XC3S500E. I have a VHDL file called core.vhd, which I double click comes up over here. But underneath that, I also have a UCF file. And if I double click that, you can see right now that it's empty. Okay. And the UCF file maps the variables in your VHD file to pins on the chip. So we need to open that guy. Now the easiest way to do that is to, in the lower window, open up this node and then double click on edit constraints. And now it takes you over to the constraints file. And you notice the UC.UCF tab is highlighted. VHDL files have a file type of VHD. UCF have a file type of .UCF. Okay? Alright, so at that point, let's see, we need to type some stuff in here. Okay? Well, I'm just going to copy and paste what I've got over here, so I don't have to you don't have to watch me type, but you'll need to type this in. And what that basically does is it maps variables in my VHDL file to the board. Now if you go to back to your VHDL file and look at your entity, you've got I0 and I1 and EQ. Those are variables. Well, those need to get mapped to pins and LEDs on the actual board. So what we're doing here is we're creating what we call a net list. Okay, so it's a list, and there'll be a whole bunch of items in there as we go through the course. And on the first one, I'm saying take the variable I0 and map it to location L13. Well, if you go look at the board, you're going to find out that L13 corresponds to one of those switches. So I'm mapping an input to a switch on the perimeter of the board. Okay? And then I'm mapping the variable I1 to another switch, and there's an L13 written next to that switch. And then I'm mapping my output EQ to F12, which is an LED in that general vicinity of the board. So now we've mapped our variables in our VHDL to physical entities on the board. Okay, so the next thing we need to do is we need to check the syntax. So in the sources pane at the top, make sure that core is selected. Now you'll notice down the bottom, as you start changing what you select on, the bottom stuff in the processes pane changes, because these are processes, these are programs that you can double click and run. But what you run depends on what you have selected up top. Okay, I want core selected, and that's critical. A lot of people don't select the right thing when they're looking for the process that doesn't exist. Alright, so right here what we want to do is we want to have core selected, okay, and then under synthesize XST we want to double click check syntax. Okay, so I'm going to double click that guy. Okay. You'll get some error or some messages at the bottom. Hopefully there will be no error messages. And it says process check syntax completed. Alright, that's good. And let me bring this down a little bit. Okay. Alright, well then let's see. At that point, check syntax, you need to look at implement design. Alright, well this is going to do all kinds of things. It's going to do a translate, map, place, and route. So what you do need to do at this point is double click implement design. Okay, now if you double click and nothing happens, you can right click and say rerun all. Okay, sometimes it gets out of sync. But now this takes a while, so it just spews out a bunch of stuff, and as you go through the course you can try to look at that and figure out what's going on. But right now we're we're trying to translate, we're trying to map, and we're trying to place. Now you notice I got a warning on my map. Well, that should normally be a green checkbox, but what's going on in that warning is yeah, what's going on here in the map is that I've got a warning there, and that warning is happening because I haven't updated my software. So it's okay. You'll probably get a green check in class. All right. So at that point, we were able to check syntax, translate, map, and place and route. You should have 3 green check marks here. Okay. So once we've done that, well, the next thing to do is to generate a programming file. Okay. So what you want to do on generate a programming file is double click that guy, and now it's actually going to create some bits that we can download. Okay, great. We got my green arrow. So yeah, we got all these green green check marks. We're good. So at this point right here, we got to start getting ready to put this guy on the chip. So what you want to do is you want to select configure target device, open up the Explorer window underneath it. Maybe open this window a little more, and then you'll see one of the nodes underneath configure target device says impact. Okay, well, you want to double click this guy, and that will start a process that'll bring up a whole nother window. And here it is right here. Here's the impact window. I'm going to shrink this down a little bit. Okay, and that happened because I double clicked on the manage configuration project impact entry right there. All right, well at this point you should see boundary scan system ACE. What you want to do right here is left click on, or actually double click on boundary scan, and that'll populate this right workspace window. Okay, and then at that point in the right workspace window you want to right click and say initialize chain. Okay, initialize chain. Now before you did this you should have powered up the board. You apply power to the board, turn on the power switch, let it completely power up, and then connect the USB cable to your PC. Okay, that should have been done just a few minutes before this step. Okay, and now at this point we were able to talk to the device through USB. Now you might get an error, in which case you might need to try other USB ports on the PC. And then it found the 3 chips. The first chip is the FPGA. The other 2 are PROMs and RAMs and ROMs that we can play with later. But the first chip in this chain is your FPGA. And then it says, do you want to continue and assign configuration files? Well, yeah, I definitely want to do that because I want to put some bits on this device. So click yes here. And now it's going to bring up a dialog, and what you have to do is go find the project we're using. Now this is not the project we're using. The project we're using I think was in videos lab 1 demo. So make sure you go to the right one. And then I called this guy core. If you remember, that's what I called my VHDL file, core. So what I want to download is core.bit. So open that guy, and then at this point it says, do you want to attach a PROM? No, we don't. Let's just click no right here. We'll say more about that later. And then it gives you options for assigning some configuration files, which will bypass, and then we'll bypass again. So you'll do 2 bypasses. Okay, you'll say no, bypass, bypass, and then you get some information here, and then you can click OK. Well, at that point you should see all the devices here, and you should say identity succeeded. Okay, so it found the device, it labeled them with the correct numbers, XC3S500, so forth. Okay. Well, at this point, all you need to do is go up and hover over the FPGA, right click and select Program. And when you select Program, it's going to download your bits. I got a little error message, and then the identify succeeded message changed to a program succeeded. So at this point you're done. Now you just go over to your board and you flip some switches and you verify that the 1-bit comparator is actually working. You'll flip switches 1 and 0 on the board. Call the instructor over, demo that, and you're good to go. Alright, thanks for watching and good luck.